Now when our model is ready, or when we are able to create our model, then we have to go for load definition. So to do it, I'll go here, load, then load type. First of all, we'll define load type. Okay, now let's say number one, then level will be dead load, and name will be dead load, and from here select the types of load. So we know we have available these 5 types of load: dead load, live load, wind, snow, and seismic. So I'll select dead load and a structure. Okay, which types of dead load will take? Dead load, then fluids or earth load. Then if you go for live load, then reducible load or unreducible load. Okay, then for wind, then for snow, they have snow, roof live load, then rain live load. Then in seismic, okay, so first of all I'll provide dead load. And which types of dead load actually I'll provide? Dead load will be here, basic dead load. So first of all it will be, let's say, self weight or something. Okay, so I'll provide dead load and then click add. Here a dead load have been added, and if you see here which types of load it is, we'll be able to see it. And click here and click here, modify, and we'll be able to modify. Let's say I want to change that name. Okay, change that name like dead load dot self weight, then click modify. It will modify. Okay, here. Then I will take another load that will be dead load, and it will be floor finish. Add. I will add another load as a dead load, and it will be floor finish. Okay, on, and let's say it will be floor finish, and it will be partition wall. Okay, partition wall, then click add. Done. Now we'll go for another load or another loading system that will be, so the dead load is okay. Now we'll go for, let's say we'll provide live load. From here I'll select live load, LL, then live load, and this live load will be floor live load F, and it will be reducible or unreducible. So I don't want to reduce any live load factor, and if you want to reduce, then you can use this option. So I'll use this option, live load, and number it will be 4. Okay, and click add. Okay, now live load floor, and they have another option that is snow. So in snow load, I can add the LR roof live load as a snow load or other load. Otherwise I can go for live load, and it will be label live load, and it will be name will be LR live load R, then reducible or unreducible, it's up to you, then click add. Okay, in this way we are able to add our load. Now if you need to add wind load, click here, wind load, and what will be the name of wind? Let's say WIND, wind, and we'll provide this wind x plus add wind x minus add wind y plus wind y minus. Okay, now if you go for seismic weight, same wind, sorry, earthquake, and we'll provide this name is seismic earthquake x plus earthquake x minus earthquake plus minus. That's it. So this is the probable load we can apply for our structure. And here we have missed something like that was our self weight, and then it is floor finish partition all, and it is good to add some water load as a dead load, fluid load. Okay, so our overhead water tank load as a fluid load, and if the earth load is available, okay, so we can also add it. So fluid load, it will also add as a dead load. I can give here water load. Okay, WL, that means water load, and click add. Here, so this is the way to add your all types of load. So in this way you have to add any load you need. So close it. Then if you come here, you'll see the list of load you have selected here. Okay, here are all available load is the load we have defined, or the load types we have defined. By using that load, finally we'll define load on a structure. Okay, now we'll go for actually now we'll assign load on our structure. Okay, to do it, I'll click here load, then load definition. If you press LD, then also you will get that option. So I'll click here load definition here. After that, they have 4 options. One is node, another is member, load on node. Okay, so what is the node? We will provide load on some definite point. So when we go for steel structure design or truss design, then we is to provide the load on node or connecting point. So there we'll use that option, let's say node, like that. Okay, and another load is member load. So what is the member load actually? Member load is if we provide any partition or load, any uniformly distributed load, uniformly varying load on our structure, so we'll use this option actually. Okay, then surface load. So what is the meaning of surface load? Surface load is nothing but our floor load or load per square feet, like something. Okay, so by using this option we are able to assign the surface load. So they have option what is uniform panel load, then another option is load on some specific point. Okay, then here some load on member load on panel. Sometimes you'll see some partition all are available on our member. Okay, so in other software we are not able to do it directly. So we used to create line, then we used to provide the load, but here this option is available. Then I will come here. So there have another load, that is pressure. So what is the meaning of pressure? This hydrostatic pressure actually. Okay, so let's say you are going to create or you are going to design any liquid container element like overhead water tank, underground water tank, safety tank, or any other element actually. Then you will be able to provide that load here. Okay, then they have another option, thermal load. Then if you come here, uniform polar load on so here this is available. Actually one by one we learn everything. Okay, now I will go to another option, that is self weight and mass. So we have to we have to provide self weight on our structure. So they have option self weight P minus Z for the whole structure. Okay, so if for whole structure we want to assign partitional load, then we can do it. Simply select this option and come here where you want to apply this load. Okay, we're able to do it. And they have another option, that is self weight for a specific member. Okay, for a specific member self weight, then we can do it. And we have another option here, body force. So if you want to press any force on a specific direction from a member, then we are also able to do it. Okay, now and they have another option, nodal mass. So I'll close this, and let's say if we go for self weight, and I'll go to ground floor where we have created. So let's say if I click here on our beam, then a load will be applied at here. Okay, a self weight, actually self weight will be applied at here. Otherwise you can click here, then select the whole member available here. Every member will be selected. Then here every member have been selected, then click apply, and our all member will be applied at here. Okay, so simply click here, any corner of our structure, like here. Okay. And if we go in 3D, we can see this member is available, and simply if we click apply, our load will be applied at. Clear? Now I'll close it, and then we'll go for another load definition. In this way we are able to apply the self weight of our structure. So in later also we'll know about that. Then the nodal load. So what is the meaning of nodal load? Let's say go to plan. So for nodal load, here I'll click on nodal load, then where you want to apply how much load. So this load are given in keep, let's say in Z, in minus Z direction, I mean in downward direction, I want to apply, let's say 10 keep minus 10 keep minus 10 keep load in a specific point. So where, let's say in that point 25. Okay, and click add. Now here we have applied it a load. You can see 10 keep 10, and the load is already given here. So in this way actually we are able to assign a load on a specific point. Then again if I go for nodal load and nodal phase force given 10, so click here. Okay, so we have selected that node to apply our load. Otherwise by clicking here, first of all click add, then you can come here where you want to add that load. In this way, in both way, you can see here a load are given. Okay, in downward direction already we have assigned that load. So if we click apply, it will be visible later. Then go close. Now if you want to see that we have applied it load or not, so you can see here this load is showing because I have click here for view, then display, and here cancel, view, display, and load. If I uncheck this option, the load will not be visible, and if I click here, all of our load will be visible. So you can see the load we have applied it here. Okay, now I'll press Ctrl Z to okay, now again I'll go here, load, then define load, and one by one I'll show you that how we can assign load here again. So click go node, then -10, and before that where we want to load, actually you have to select it. Let's say I want to assign load in this point. Okay, this point actually. So to do it, first of all, I'll go here, node, then it's 10, click add, and see the node will be applied at in 13, the point 13 node, and click apply. You can see load is available. Again, click here, simply click where you want to apply or in which node you want to apply. That's it. Now we'll learn about how we can assign distributed load on beam. Okay, so to do it, again goes load, then load definition. From here, the member load. In previous lecture we have or previous session we have learned about node. Okay, then we'll go for member load. Now how we'll assign the member load? I'll click here, then here we have to provide the load. So what will be the load actually? I'll close it. So what will be the load actually? And if you double click here, you will get a calculator here. So no need calculator. So let's say in Z direction, I mean in bottom direction, I'll provide a all load. So what will be the all load actually? Let's say 0.5 kip per feet load will provide. Okay, and what will be the angle? Angle will be 0. That means our load will be directly to the bottom. Then we'll provide that load for this global direction. Okay, and click add. So we have added it. Now click here or click here apply, then select the member where you want to apply this load. See, the loads are showing here. Sometimes you will not see it. Why? If you go to view, then display, then go to loads, and here for first time it will be unchecked, and click apply, it will not show here. So I'll click here to see it. Okay, now I'll go to 3D view, and here see also this load are not showing. So to show, click here and click here. So you can see this load, and what is the red actually? The red portion are showing the self weight, and here the provided load are showing here. See? You can see the distributed load. So here is the distributed load we have provided recently. This is the way to provide our distributed load. Now if we want to provide, I'll close it, apply, and close it. Now if we want to provide trapezoidal load like that, trapezoidal load like that, so how we'll do it? So to provide trapezoidal load for 2 points, for 3 points, for 4 points, okay, at which types I mean in which situation you want to provide it? I'll go here for 2 points. So our sometimes we need a triangular load, then we can use this option P1, P2, P3. Then I'll go for 2 points. So let's say our load on our first point will be 0. Okay, and load on our second point load on our second point will be let's say 0.5, and it will be minus 0.5. okay, it will be minus 0.5. And before providing any loads, click here where you want to apply the load. So I want to apply load global direction and in z direction, z global direction. Okay, here from where to where. So this is the starting point of our beam. This is the starting point of our beam. So from this point to this point, this is the axon. I mean, at how much distance away you want to start providing your load. So let's say I want to start providing our load at 0, and I want to start providing our load at the end. Okay, so this is the factor z and the angle. So we'll not provide any angle. I'll click add. Now click apply, and where you want to provide the load. Let's say I'll provide load here. So you can see the load is 0.5. Now if we go to 3D, you can see the load have applied it from this point to this point. Now again I'll go here and I'll provide here. So our first point, actually you have to use this value as a relative value. They have two options, relative and absolute. So what is the meaning of relative? Actually, the meaning of relative is when we'll go for applying load, then we'll divide the distance with total distance. Okay, and let's say from this point to this point we have a distance of 10 feet, and if I divide with that value with 10 feet, then I'll get 1. That means I'll just get a scale actually. So if you want to apply your load from this point to this middle point, then how will go for it? So it's simply here I will first point will be 0, second point will be 0.5, and let's say everything will be same. Then click add, then apply, and click here. So you can see from this point to this point we have applied a load, and this value is here. And also if I go here and I provide 0.75, so apply and click here, and see from this point to this point this load will apply it to 2/3 of our total beam. So again if I go to plan, and let's say if I want to apply this load for a specific distance, so let's say from this point to this point, or from this point to this point, our total distance is 0 to 10. Okay, now for first 8 feet I want to, from this point to from starting to this point till 8 feet I want to provide our this load. So what we'll do, I'll just go here, I'll double click here, and I'll provide total 8 divided by 10, as the total distance is 10. So I'll get 0.8, and I'll click OK, and see here we are getting the value is 0.8. Now if I click add and apply, then if I provide load here, and if I go to 3D, you'll see we have provided load this point to this point, and this value is from this point to this point is total 8 feet. Okay, in this way you are able to provide your distributed load. And now if you go for another types of load, let's say, and let's say if load of this point is minus, let's say this point load will be 0.2, click add and apply and click here. See, in starting we'll get the load 0.02, and here we'll get like that. And also if we go here and we go for 0.3, so let's say in top point our value will be 0.8, and this is the middle point, and this is 1 for the last point. Okay, this is for 0. Then for this one, this point will be top point will be x2, or 0.5 means already I have shown you how we'll calculate it. Then everything is okay, and just this value will be minus, and z global add apply, and apply this load here. You can see from 0 to 0, and at midpoint we'll get 0.85. So this is the way to assign our member load. Okay, also there are many options: uniform moment, then member force. Okay, if we click here, now let's say F. So what will be if you want to provide any point load on a member, let's say in the middle of this member I'll provide a minus 15 keep load. Okay, and 15 keep load here. And what will be the distance? So they have two options actually. If you know the distance, let's say here I know the distance, I know this distance, then I will use absolute distance. And here I want to apply the load after 9 feet, then click add, then and select this member. You'll see, sorry, from this point to this point, this load have been provided here. Again, go here, and if I provide for 1 feet from this point to this point, actually how the software will consider that who is the first and who is the last. When you have started drawing, then which point you have taken as the first point and the second point you have taken as the last point, software will consider that. Let's say in that beam I want to assign a point load 15 kit after 5 feet. Okay, so click add for absolute distance, add, then apply, and select this beam and click. See, after 5 feet from this point to this point, after 5 feet we are getting this point load. Now again, if you want to apply another load, like load with moment, let's say moment will be 15 or 25. Okay, everything will be okay, and here this value will be 10 for absolute, and click add, then apply, and click this beam. See, here a moment have been applied it, and a load also have been applied it. So this is the way to apply all types of load. Okay, thank you very much. Now we'll learn about surface load. Okay, so after nodal load, member load, self weight, then we'll go for surface load. So to apply load on surface, okay, to load apply on surface, we have many options, already have discussed. So as we are using horizontal slab, then we'll use this option, uniform load. Okay, so to provide uniform load, P, the load of P, uniformly distributed load P, that will be, let's say 0.1. That means 100 lb per square feet, or 0.1 ksf. It should be minus, already have discussed why. So then click add, and then click apply, and just select the slab where you want to apply this load. Let's say I want to apply this load on this circular slab. Just click here, you will see a load have been applied it. Again click here, a load have been applied it. Then if I click here, see, a load have been applied it. Everywhere I'll click where a slab is available, a load will be applied it. Okay, let's click here, that's it. If you click here, see, a new load have been applied it. Now if I go to 3D to see that, see, here we can see this load are showing. Now if I go here, view, then if I go to display, then loads. Now for loads, okay, which types of load I want to show. Let's say linear and concentrated load will not see right now. Now see, only the distributed load are showing here. So this is the way to apply our distributed load on our structure perfectly. Okay, now they have another option, like again I'll click here, apply. Okay, now let's say we have a all over the beam. Okay, so in this beam, in this slab, or in this slab, so how I'll do it? They have option linear load for 2 point and P1 P2. So let's say for Z, load will be 0.5 minus 0.5, and it will also be 0. Minus 0.5. So both load are 0.5 global. Then click add incorrect parameters. So minus 0.5, 0.5. Okay, first point. Let's say I'll click this point as a first point. Let's say this point as second point. Okay, then click add, and you can see a load have been added here. And if I go to 3D view, you can see here we're seeing a load. Okay, so this will help us when we need to apply a load on slab for a partitional load or any other load which act as a line load. So thank you very much. Stay connected till next lecture.